Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I wanted to do another code review for you. In this particular code review we're going to predict sales on Walmart. And basically what I did was I used several models and selected the best model. The models that I used was an artificial neural network, linear regression, and random forest regressor. And those were the models that I used. And it's very interesting because, TensorFlow is supposed to be the ultimate library, but I found out recently that it's not because there's another library that's superseding it. But sometimes your models from sklearn work better than the models from TensorFlow, and this is one example of when that has happened. And what I did was I used several models to see which model worked the best, and the model that worked the best is the one that I chose. And then I got an RMSE, that's root mean squared error, of 366 on the leaderboard, which isn't too bad. So it's one of the things that's problematic about this sales prediction is the fact that it was based on the year 2014, and then the training set was for, I think, 2006 or 2007 to 2013. So the training years were different from the test years. And I looked it up on Google to see how to predict on sales, and it says you're supposed to predict on the number of customers times the average sales. Well, this particular set didn't give us the number of customers, and since it didn't give us the number of customers, then I couldn't do that. But we'll go ahead and do the code review so you can see what I did in the code review to come up with the best score of 366.96. First thing we're going to do is we're going to define our problem statement, and the problem statement is predict on Walmart sales. And then the second thing that we're going to do is we're going to import the libraries that we need for this particular problem. So we're going to import NumPy as NP, that creates your NumPy arrays, and it also performs numerical computations. We're going to import Pandas as PD, which creates your data frames in your series, and it processes data. We're going to import OS because it goes into the operating system and it retrieves the files. We're going to import TensorFlow as TF. That's going to create your neural network. We're going to print the version of TF, and it's 2.12. And you always need to print the version of TensorFlow because this library goes through so many changes. We're going to import matplotlib.pyplot SBLT, so that's going to visualize your data. And we're going to import Seaborn as SNS. That's going to statistically visualize your data. We're also going to import sklearn, which is going to provide your machine learning functionality. We're going to set the seed. You need to set the seed. So when you set the seed, it ensures that every time you run the program, it runs the same. So tf.random.setSeed is 42 and np.random.seed is 42. We're going to suppress scientific notation. pd.options.display float format equals, and then it gives you the format that you're supposed to use. So that's going to suppress your scientific notation because I don't want to see scientific notation in my predictions. we're going to load the files in the program, and these are the files that we're going to get. The only files that I really looked at were the train test and submission. You get some Excel files, so macroeconomic, weather data, events, holidays data, attributes, descriptions, but I didn't even look at those because they were Excel. But I guess you could look at those if you wanted to. If any of those had like the number of customers, then the number of customers would be good, because that's how you predict the sales. You predict the sales on the number of customers times the average sales. And this is, I looked it up on Google, and it said sales forecast estimated amount of customers times average value of customer purchases. So that's how you predict your sales if you don't want to use machine learning. So we're going to use pandas to read the files. So train is your train CSV, test is your submission CSV, and Kaggle submission is your Kaggle submission format.csv. So here's your train file. It gives you the year 2009 to 2013, the month, the product category, and the sales in thousands. We do info, and then you can find out that they are year and month are integers, product category is object, and sales is a float. We check for null values. We have 10 null values. So we just drop those null values from the train, because the null values were actually in the sales in thousands. So we just dropped that. The test file had some unnamed columns, so we just wanted to remove those unnamed columns. So test equals test.iloc, all of the rows, and then 0 to 3. So that will give you 0, 1, 2 as your test, and you can see that it's 2014, a month, and a product category. And you've got to predict on the year. One thing that you could do, really, when we get into this, I'll show you, is you can find out how much the average income increased from year to year. And then once you find out the average income increase from year to year, then you can add that increase to the train file, test file, and then multiply that increase by the prediction, and that might be a good thing. Increase in sales from previous year. That might be a good way to check the check the prediction. That's just something that now that I just thought about. So that is a good reason why I do these code reviews, because these code reviews actually help me to think of other things. So I could tell the increase or decrease in sales from year to year. And then once I know that the increase and decrease in sales from year to year, I can add that to the 2014. And when I add that far we don't have any missing values, which is good. And this is the Kaggle submission. And so what they did on the Kaggle submission was they didn't do it correctly because they said year, and then they said 1 to 36. So basically, what it is it's 1 year, but it's 1 year, but you've got 3 different product categories, which gives you 36. Now we're going to analyze the training file. So we're going to create a histogram of the label or the target. So you can see this is the histogram. We're going to check the box spot of the year. So you can see that the sales increase from year to year. So you can determine, what's the increase in sales from 2009 to 2010, what's the increase in sales from 2010 to 2011, what's the increase in sales from 2011 to 2012, and what's the increase in sales from 2012 to 2013. And then you can add that increase. And then when you add the increase, then that might actually help you to improve your score on the test score. And that's just something that I just now thought up. So when I finish this code review, perhaps I will try to do that and see if I can improve my score, because that's what it's all about, is improving your predictions. If you want to get a job as a machine learning specialist, you need to know all of these techniques to improve your predictions. And since I'm doing this by myself, I don't have a mentor, so I just have to kind of figure it out on my own. I have to look at sample code, but this particular competition question didn't have any sample code, although I made my code public. And now we check the month. You can see that the month of December had the highest sales, and the month of January and the month of September had the lowest sales. So you can see that. And now we check the product category. You can see that women's clothing had the highest sales and men's clothing had the lowest sales. So we're going to encode the product category, and then rather than using a label encoder, since it was only 3 categories, I used a dictionary. And then that's what I did in the training and the test file. So now the product category is going to be 1, 2, 3. I'm going to define my X and my Y variables. Y is your target, X is your train, X test is test. Check for any null values. We don't have any null values. Check for any null values. And then what happened was for the year 2014, because it was just 2014 for that year, what happened was I had to make X test year 2014 to eliminate the null values. And the reason why is if you have a column with all of one W, then you're going to have problems making predictions. So I had to go in and reset it to X test year being 2014. Now we're going to use sklearn's train test split to split the data set up into training and validation sets. We're going to use random forest regressor try to determine the increase or decrease from one year to the next, and then add an extra column and see what happens. See if that actually improves my error, because that's the name of the game, getting the best error that you possibly can. So I'm going to go ahead and conclude this video. If you like my video, please like, subscribe, and share. Thank you for watching my video. If you want to be notified whenever I make new videos, please tap onto the bell button next to the subscribe